So the bell work states, if we just choose a random term and we call it a sub n, we don't know where it is, we don't know what value it is. What would a sub n minus 2 be then? Yes? 2 terms before. 2 terms before. Ugh. 2 terms before. Well, if that's 2 terms before, then plus 3 must be 3 terms after. And then plus 100 must just be 100 terms after. All right, what questions did we have from the homework? Yeah.
Number 6.
So number 6 is 1/3, 2 9ths, 4 27ths, 8 81st. So we're going to notice on top we are multiplying by 2. So that's times 2, times 2, times 2. And on the bottom we are multiplying by 3 times 3, times 3, times 3. All right, so a sub n is going to equal, since we're multiplying on top and bottom by a number, it's going to be exponential. And on top we're going to have 2 to something. And on the bottom we need to have 3 to something as well. Well, if we look at a sub 1, our very first one, so let's just say a sub 1. What do I need on top on a sub 1? I need a 1. I need a 1. And 2 to what power gives me 1? Yes, 3. 0, thank you. I know it's rough. It's some rough questions we got going on here. So we have 2 to the 0th power. So that has to be n minus 1, because my n is 1. 1 minus 1 gives me my 0. And then my bottom needs to be 3. So my bottom needs to be 3 to the first, which would be 3 to the n. Because then a sub 1 would be 2 to the 1 minus 1 over 3 to the 1. 2 to the 0th over 3 to the first is 1 over 3. And everything else we'll check out after that. Does that answer your question? All right, so I assume you already had the bases, right? The 2 and the 3 is just what you had to do to the top one. So you just got to ask yourself, what do I need for that first thing? And you need to create it by using n, right? n plus 1, n plus 3, n minus 1, n minus 2. Okay, so you got to think kind of ahead to get where you're at. Okay, other questions? Yeah. Number 5. Number 5 is number 5. So if I do adding, it'd be plus 2, but then it'd be plus 4. Nope, scratch that. Why can't I add? Plus 4, there we go. Plus 4, plus 4, plus 4. It'd be plus 4 all the way across. Today it's going to be much easier to do this one, but in short, it's a linear equation. So we said yesterday that it'd be a sub n equals, we carry down that 4, and we call it 4n. And then to figure out what we're adding or subtracting, I just go a to the first needs to equal 3. Well, right now we have 4 to the n, so that'd be 4 times 1. Well, I would need to subtract 1 to get that 3. So this would be 4n minus 1. That's one of the options. There's actually 2 ways to write that. All right, we'll go through the other way. Did you have the other way?
I was trying to get the other way. I didn't get there.
Oh, you didn't get there? Okay. Well, the other way we would have ended up having is, so our starting position, so the other way we could have written this is we could have did 3 plus 4 times n minus 1. That would have been the other way to write that. After today, it'll be much easier to write these. All right, it's just going to be plug and chug. As soon as we know it's linear or arithmetic, we'll be able to immediately plug those in rather than looking for patterns or anything. Okay, other questions? I did want to go over one if there's no questions about it, and it's this one right here because I changed the notation up. I change it up because normally I would have a sub n equals something. And it's not the k that should have thrown you, it was the fact that it's a sub k plus 1. So that's a sub k plus 1. So algebraically, kind of how this looks is, well, we already know that the first one is equal to 3. If I have a sub 2, and I plug that 2 in, I need to figure out how to rewrite this in the fact that it's k plus 1. Well, the only way I could rewrite that would be a sub 1 plus 1, which would make that k value that 1, which means that would equal 2 times a to that 1 minus 1. So that's how it would look algebraically. Now, me just saying it in words would be, I always start on this side, the term I want. This is the term I want. The term I want is going to equal 2 times, this a of k is 1 less than this one. So if this one's 3, this one's 2. If this one's 4, this one's 3. So this is just the previous term. So this just says the term I want equals 2 times the previous term minus 1. Well, looking at it algebraically, yeah, that works. A sub 2 equals 2 times a sub 1 minus 1. So if you can't say it in plain English, or you don't understand what they're asking for, just rewrite it in the way they want it. All right, a sub 2 has to be a sub k plus 1 or 1 plus 1. So a sub 3 would actually be a sub 2 plus 1. Okay, so there's multiple ways to do that, but this is fine notationally. I can start you at a sub k plus 10. And then I'd write this one as a sub k plus 9. That would be the term before it. But it all works out. Okay? I'd have to change this value, but otherwise it would be fine. All right, other questions? Because I wanted to make sure we did that one. No? We're good on all the factorial ones? Okay. Yes?
12.
For 12. So this one's going to be, well, 2n minus 1 factorial would be 2n minus 1 times 2n minus 2 times 2n minus 3, and we just keep going from there. Because in fact it would just be 2n minus 1, 2n minus 1 minus 1, 2n minus 1 minus 1 minus 1. And then the bottom is just going to be 2n plus 1 times 2n plus 1 minus 1, which is just 2n. And then it goes to 2n minus 1, and we just continue from there. So all of those would cancel out, and all we would just have 1 over this 2n plus 1 times 2n, or you could have distributed it. Okay? It's just all about, you have to know how to write these out in order to simplify them. Because your calculator can't do this for you. So you have to know how to write these out. Other questions? Because every time I go over one, I see a bunch of people writing it down. Yeah. 14. 14 is n plus 2 factorial. So rewriting that is just going to be n plus 2. We always do our starting. And it's times n plus 2 minus 1, which is n plus 1. And then it's n plus 1 minus 1, which is just n. And then it's just dot, dot, dot. I'm going to stop there, because I know the next one is n times n minus 1 times n minus 2. So this n and everything else is going to cancel out. We're just going to have n plus 2 times n plus 1 on top, and we just factor that. Or not factor, distribute. FOIL, if you will. Okay, now let's go ahead and get into today's lesson. All right, so today we're going to talk about arithmetic sequences. This is what we've already been doing. That was what that question Brian asked at number 5. An arithmetic sequence. Well, an arithmetic sequence is just a sequence whose consecutive terms have a common difference. And what that means is to get to every single term, either I add by the same number or I subtract by the same number. There's no multiplying, there's no dividing. You have to either add to get to every single number or subtract by that same number over and over and over. That's what the common difference is. So in other words, what I just said is the gaps between them need to be a constant. So our second term minus our first term has to equal our third term minus our second term, has to equal our fourth term minus our third term, which equals d, and that d is called our common difference. So when I ask for common difference, we're just going to have d equals some number. And that common difference, like I said, is just that, do you add 2 over and over and over and over? That's your common difference is 2. Do I subtract 10 over and over and over? My common difference would be a negative 10. If we don't have a common difference, then it is not arithmetic, and we aren't going to solve it today. We're just going to put not arithmetic, cannot solve. All right, so some examples. I'm just asking you, are the following arithmetic sequences? If so, we're supposed to state the common difference. So when we're given these numbers, I got 1, 5, 9, 13. To look for arithmetic, I'm just looking, is there a number I can add all the way throughout or subtract all the way out? Yeah?
Number 4.
Yeah, 4. Because to get from 1 to 5, I just add 4. To get to 5 to 9, I add 4. To get from 9 to 13, I add 4. And so, yes, it is arithmetic. And so we can find our d, and our common difference is just 4. So it is arithmetic. I should probably write that. And our common difference is 4. Here's a hint. Fractions can be tough when they have different denominators. It's hard to see whether you're adding, multiplying, or what's actually happening between them. So anytime I give you fractions, or anytime you see fractions and you see it as a sequence, what you're going to do is you're going to try rewriting them as having a common denominator. All right? Then you can see if you're adding or if you're subtracting. So I'm just looking at 6. 3 goes into 6, 2 goes into 6, so I'm going to create a common denominator of 6. So rather than writing 1, I'm going to write 6 over 6. 7 over 6 is already good. I need to multiply 2 by 3, so that's going to be 8 over 6. And the other one I have to multiply the top and bottom by 3 to give me 9 over 6, and that's as far as I need to go. Well, now I'm going to look at the numerator. It's just going 6, 7, 8, 9. And my denominator stays the same, so I must be adding. I must be adding, and we are just adding 1 over 6. So to get from 7 to 8, I just add 1 over 6. To add from 8 to 9, I'm just going to add 1 over 6. So we're just adding 1 over 6. I should put plus signs on everything because we could be multiplying. So that means it is arithmetic. And our common difference, or our d, is just 1 over 6. So it's arithmetic, and I came up with the common difference. Look at the next one. Take your time, look at it. Is this one arithmetic? Callie, you're shaking your head no. Why isn't it?
Because it's going up by 3, 5, 7.
Yeah. So if I look for a common difference, my first idea is maybe it's a 3. But then this one's plus 5, and right there I can say it's not arithmetic. Right there. I'm going to do the next one just to show, but so that means it's not arithmetic. And that's all we have to put in this section for now. All right, could be another one, but we're not going to learn that for a couple more sections. So right now we're just worried about the adding and the subtracting one. All right, and getting our common difference. There's two ways we can write any sequence, and we talked about this yesterday. It's recursive and it's explicit. Remember, recursive is based upon numbers before it. Well, recursive is almost always the easier one to write. Our recursive one for this one is going to be a sub n equals the previous term, a sub n minus 1, plus whatever our common difference is. All right, explicit. Explicit has two possible forms. Our explicit has two possible forms. Our first one is going to be a sub n equals our very first value, or a sub 1, plus our common difference times n minus 1. Well, we can almost derive our next explicit formula because it's just based upon this. It's just simplified. So if I distribute this d, I would have d times n minus d. So we have d sub n. So my other explicit form is going to be a sub n equals d times n plus c, where this c actually equals a sub 1 minus d. This is just a simplified form of this one. All right, most of the time I go straight to this one, and then I simplify if I want to. But either one of these are okay to write as our explicit form. Most of the time I'm going to write this one. I'm going to go from here, and then I'm going to write this one because this one's easier to work with. All right, let's go ahead and practice writing both of these. I'll give you seconds. People are still writing. Okay, in these examples, it says to determine whether each sequence is arithmetic. If so, write two formulas. When I say write two formulas, that means recursive and explicit. All right, those are the two formulas that you're going to write. So the first thing we're going to do is we're going to tell whether it's arithmetic or not. So this is plus 4, this is plus 4, and that's going to continue and continue and continue. I'm going to note two things here. I'm going to note what my first term is, so I'm going to say a sub 1 equals 3, and our common difference is going to be 4, because we need both those facts to write our recursive and our explicit formula. All right, I'm going to start with my recursive. So recursive is a sub n equals the term before it, and it's just minus our common difference. But we know our common difference. Our common difference is 4. It should be plus 4. However, something very major is missing from this formula. Jacob, if I cover up these numbers, are you going to be able to reproduce this entire set from that? Now, why not?
You don't know what a sub n is.
I don't know what a sub n is, right? Well, I don't know what my starting position is, right? Because you might say, well, I'll start at 4. I'll do 4 plus 4 is 8. 8 plus 4 is 12. So you need to, whenever you give a recursive form, you need to say what your starting term is. Or at least you need to give some point in that sequence. So whenever you're doing recursive, the easiest way to simplify this is just do your first term and say your first term is 3. So whenever you're doing recursive, you always need a starting value. And in fact, you may need 2 starting values. Your recursive might be the term before and the term before that, which would mean you need your two starting terms. So you need as many terms as it takes to fill in this first equation. All right, otherwise we don't know the starting value, and if I give JP this on the test, and I said you have to write the exact one I'm thinking of, go, write it. No. Say out loud, what formula could you come up with for this one? Make one.
A sub n minus 1 plus 5.
Okay, so that's 6. I started at 100 though, so you failed the test. So you need this. You need this. You need the starting value. Okay, so that's recursive. Explicit. Our explicit, that's going to be a sub n equals our starting term, which is 3, plus our common difference times n minus 1. Or you can rewrite that as, well, I would distribute this 4, so I'd have 4n minus 4. 3 minus 4 is negative 1, so we could rewrite this as 4n minus 1. So you can write either one of these. So this is an or kind of thing. I prefer this one. Makes your life a lot easier. Like plugging numbers into this one takes a little bit longer than plugging in numbers here. But both are the explicit formula. All right, our next one is 5, 2, negative 1, negative 4. We must be going down, so we must be using subtraction. So that's minus 3. This is minus 3. This one is minus 3. So yeah, it is arithmetic. So I'm going to state two things. I'm going to say what my first term is. And I'm also going to say what my difference is. My difference is going to be negative 3. All right, so those are the two important facts that we need out of any arithmetic formula in order to write our recursive and our explicit. So let's go ahead and write our recursive. That's usually the easier of the two. Recursive. Our recursive is always going to be a sub n equals the term before it. And then we're going to subtract 3. What am I missing from my recursive formula? Brian? My starting value. So we need to have a sub 1 is going to go ahead and equal 5. All right, now let's get our explicit. Our explicit is going to be a sub n equals our starting value, which is 5. Now we can either have plus negative 3, or I'm just going to say it's negative 3 times n minus 1. Or we can write a sub n equals, distributing that negative 3, I'd have negative 3n plus 8. Now note, we don't have to ever say our starting value for our explicit, because it's already built into it. This is already a starting value, right? And plus, explicit isn't based upon ones before it. It is just based upon which n I'm looking for when we plug it in. This one's based upon the ones before it, so you have to start it off for the person that's reading it. You have to say, we start here, and then continue from there. All right, so recursive, that's the only one you need to have a starting value for. Explicit, you do not. All right, our next one. Well, we have 2 to 6, 6 to 18. Oh, well, that's cool. I'm just going to multiply by 3. That means it's arithmetic because my common difference is 3. And so, what? Why are people's hands up? Is it not by times 3? Is it times 2? What did I multiply wrong by? Oh, you can't multiply in arithmetic. Oh, so we have no common difference. So this is not arithmetic. Not arithmetic. You cannot multiply. Has to be adding or subtracting. So that's your answer to this one. So if I give you a long, big section to fill out, don't feel completely ashamed of writing not arithmetic, because that is our answer right now. Okay, so we have that big blank, but the answer is not arithmetic. All right, the last one's kind of a beast of a different color. Just in the fact that, do I know my starting value? Do I know what my common difference is? I have to figure out both of those. And it only takes two things, and we also need to know it's arithmetic. All right, so I'm telling you right now this is arithmetic. All right, we need those two things, and we can figure everything else out from there. Let's just set it up. Let's set it up and see what information we know and how we can get the rest of the information. So what I'm going to do is I'm going to go ahead and write a sub 1. I don't know it. A sub 2. I don't know it. Well, we're doing really good so far. A sub 3, well, that's 15. All right, all right. A sub 4, oh, I don't know that one. A sub 5, nope. A sub 6, good luck next time. A sub 7, negative. A sub 8, yeah, I know that one. All right. That's the kind of table I like to see. Two values. I'm going to slide that over a little bit more. I don't quite have the room. I forgot that that slides it over a little bit up on the screen. So I'm going to slide that over a little bit. You could trial and error, adding some numbers and seeing if you get up to 50. Probably not the best bet, especially if I give you like a sub 3 is 15 and a sub 100 is some number. Because you don't want to guess and check all the way up to 100. So let's do this smartly. Let's look at the fact that if I was doing trial and error, I would pick a number, say it's 2, and I would do 15 plus 2. And then I would add 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 2, and I'd hope it equaled 50. It doesn't, because 2 is not the common difference. Well, if I did that trial and error, I would say I would add 2 here. 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 So I'd add 2, 1, 2, 3, 4, 5 times. So the way I look at that is it's 5 steps. I have 5 steps that I'd have to add 2 to, or whatever our common difference is. So we have 5 steps. So rather than just guessing and checking, I'm going to set up a formula. I'm going to say, hey, if I am looking for, I'm going to get rid of my middle section. Sorry, I just don't have the room. I'm going to say, well, a sub 8. A sub 8 is going to equal a sub 5. But I'm going to add some number to it 5 times for those 5 steps. So I'm just adding 5 times some number. I'm going to call it my common difference, or D, but you can put whatever variable you want in for there. Well, I know my 8th step. That's 50. That's going to equal, oh, not a sub 5. It should be a sub 3. I sensed the awkward silence when I said that. I got 5 in my head from counting all those steps. A sub 3, right? A sub 3 plus whatever that thing is 5 times. So it's a sub 3 plus 5d. Well, a sub 3 is going to be 15 plus 5d. I'm going to go ahead and subtract that 15 from both sides, which would be 35. Divide by 5, and we're going to see that our d, or our common difference, equals 7. Now you could check that in your head. You could add 7 5 times the 15. It's going to come to 50. All right, now that I know the difference is 7, I can easily find my first term by simply going 15 minus 7 is this one. Whatever that is, minus 7 is going to give me that one. It's going to turn out as 1. Let's pretend real quick that that isn't a good idea. Let's pretend like I'm at term 50, and I don't want to figure out the 49 before it. Well, we can use this exact same equation to get back to 1. And how that's going to work is we're just going to say, well, a sub 3 is going to equal a sub 1 plus, and we just got to count how many steps it would be. It'd be 2 steps. In other words, you can just do 3 minus 1. 8 minus 3 gives me 5. But it's 2 steps, so it's plus 2 times whatever our d is. Well, I know my third is 15. That's going to equal a sub 1 plus, and my common difference is 7. That's 15 minus 14, so a sub 1 equals 1. Same number we came up with before. 15 minus 7 is going to be 8. 8 minus 1, or minus 7 is going to be 1. Either way, our a sub 1 equals 1. I would probably just subtract 7 twice. But I'm saying, what if I give you a sub 25, and you have to go all the way back to 1? All right, well, I got my common difference. I got my first value. I'm going to pretend like I didn't erase that line, and it just shifted over there. So my recursive is going to be a sub n equals a sub n minus 1. So the term I want equals the term before it, and it's just going to be plus 7. And I write that down. Mr. Pavement gives me 100% for that question. Right? Mr. Pavement's like, hey, you nailed it. I know exactly what thing you're... No, I don't. Brian? I need that first term. You have to remember that for recursive, and it's just for recursive. I mean, if you wrote, so let's pretend that we did our explicit, right? We're doing our explicit. I'm doing my explicit, and I'm saying a sub n equals my first term, which is 1, plus my difference times n minus 1. And for some reason I say a sub 1 equals 1. Can I really take off points for that? No, I can't take off points for that. So if you're ever in doubt, just list the very first term. All right, when in doubt, list that first term. Or we could have written a sub n equals 7n minus 6. Questions, comments, concerns? Test corrections are due Friday. Please, if you haven't already, take that survey. They're starting to slowly trickle in. I got like 55 out of 80 some, so we're getting there. We're getting there. But please, if you keep forgetting, just get it done. Put it on a list of things to do. It takes... Who's done it? How long does it take? Like 5 minutes? Yeah, between 2 to 5 minutes, depending on if you put in statements or not.